welcome back to the Explainer. Okay, I want you to picture something for a second. You open up a code repository, you navigate to the routing file, and bam, you are immediately hit with a 1,000-line Express script. It's this massive, tangled wall of code where routing, request parsing, business logic, and database calls are all just mashed together into one giant headache. Look, we've all been there, and frankly, it makes maintaining an app a total nightmare. But what if we completely rethought how our applications receive traffic? Today, we're focusing on day 2 of NestJS, and we're diving deep into controllers. We're going to look at controllers not just as lines of code, but through a really powerful architectural analogy, the reception desk of your app.
Consider today's Explainer your official employee orientation for running that reception desk. We are going to master 5 essential tools today. Number 1, the traffic cop. 2, signage and decorators. 3, extracting the data. 4, delivering the response. And 5, mastering async operations. All right, let's get into it. Starting with Section 1, the traffic cop.
To kick things off, we really need to shift our mental model away from writing unstructured, random routes and move toward designing a clear architectural layer. According to the NestJS documentation, a controller is a class responsible for handling incoming HTTP requests and sending responses back to the client. Period. That is its absolutely only job. A controller is strictly a traffic cop, or, a front desk receptionist. When an HTTP request comes knocking on your app's door, the controller greets it, figures out what it wants, and then delegates all the heavy lifting to the hotel manager, which in the NestJS world is your service layer. The controller shouldn't be doing any complex business logic itself. It literally just routes the request, waits for a result, and hands that result back. This separation of concerns, it is the absolute secret to keeping your application clean and scalable.
Moving right along to Section 2, signage and decorators.
Now that we have our receptionist, how do we physically set up the routing signage so incoming requests know exactly where to go? Well, Nest relies heavily on TypeScript decorators to link classes with the necessary routing metadata. You start by adding a class decorator, something like @controllerCats, and this acts as a required prefix for the entire class. Then you drop in method decorators, like @getBreed, for specific functions. What's really amazing here is how NestJS intelligently combines them. It takes that class prefix in the method path and seamlessly maps a GET request to /cats/breed. It just eliminates so much repetitive code. You don't have to type the word cats for every single route in the file. And of course, Nest provides decorators for the whole shebang of standard HTTP methods: post, put, delete, patch, you name it.
But what about more complex scenarios? Beyond the basics, NestJS also gives your receptionist some advanced traffic control mechanisms. You can use pattern-based wildcard routes, like throwing in an asterisk to match a flexible combination of characters at the end of a path. Plus, the @controller decorator can even accept a host option, which allows for subdomain routing. This means you can dictate that certain controllers only handle requests coming from very specific subdomains, like admin.example.com. That is incredibly useful for highly dynamic traffic scenarios. Okay, that brings us to Section 3, extracting the data.
Knowing where to route traffic is only half the battle, right? When a request arrives, it usually brings some baggage with it, sort of like intake forms. Let's see how our receptionist handles them. What's beautifully declarative about this process is how NestJS just takes care of the busy work. In a traditional Node app, you're probably used to digging through the request stream, manually parsing rec.body or rec.query. Well, NestJS eliminates that entirely by providing built-in parameter decorators. Need a dynamic value from the URL path? Use @param. Need to filter by a query string? Drop in @query. Want the entire JSON payload of a post request? Just use @body. You literally just decorate your method parameters, and Nest hands you the exact data you asked for on a silver platter. Now, when we extract a payload using something like @body, we actually need to define what shape that data should take. This is where DTOs, or data transfer objects, come into play. A DTO specifies the exact schema for your network data. But here is a super crucial detail straight from the documentation. While you technically could use a TypeScript interface, Nest highly recommends using ES6 classes for DTOs. Why? Well, because TypeScript interfaces are stripped away during the transpilation process to JavaScript. They literally don't exist at runtime. Classes, on the other hand, remain intact. And this is absolutely essential, because NestJS's built-in validation pipes need to access the metatype of these objects while the app is actually running, so we can automatically validate your incoming request data.
All right, let's jump into Section 4, delivering the response. So our receptionist has taken the request and sent the intake form to the back office. But what happens when the job is actually done? NestJS provides two different ways to manipulate responses: the standard approach, which is highly recommended, and the library-specific approach. The library-specific approach relies on the underlying platform's native response object. Think of Express's res.status.send. While this gives you full low-level control, it inherently makes your code platform-dependent and honestly quite a bit harder to test. The standard approach, on the flip side, is elegant, it's automatic, and it keeps your controllers completely isolated from the underlying HTTP server implementation. So here's the crucial point. With the standard approach, all you have to do is return a value from your controller method. That's literally it. If you return a JavaScript object or an array, Nest automatically serializes it to JSON for you. If you return a primitive type like a string or a Boolean, it sends the value directly. Nest handles the entire response envelope. It even automatically assigns a 200 OK status code or a 201 created status for post requests. And if you ever need to tweak the status code or add a custom header, you can just use the declarative @HTTP code or @header decorators. It just keeps your code incredibly clean and focused purely on the data.
Quick heads up though, I have to give you a warning straight from the documentation. If you decide to inject the native response object using the @res decorator into your method, Nest detects this. It assumes you are taking full manual control. And if both approaches are used at the same time, the standard automatic response approach is automatically disabled for that single route, meaning your server will actually hang if you don't manually send a response. If you absolutely must inject the response object, say you just need to set a specific cookie, but you still want Nest to handle the return value automatically, you have to explicitly set pass-through to true in your @res decorator. Definitely keep that in mind.
So, up to this point, our reception desk is running flawlessly. But let's ask a really important question here. What happens when a request takes too long to process? What exactly does our receptionist do when the hotel manager, our service layer, takes a few seconds to query a database or reach out to some slow external API?
Which leads us perfectly into Section 5, Mastering Async Operations.
A good receptionist doesn't just freeze up and block everyone else waiting in line, right? They multitask. Because NestJS embraces modern JavaScript, it is built from the ground up to handle asynchronous data effortlessly. Every single async function you write in your controller can return a standard JavaScript promise. Nest is smart enough to recognize that deferred value and will resolve it automatically before sending the response. But Nest takes it a step further. It also natively supports RxJS Observable streams. If your route handler returns an observable, Nest will internally handle the subscription, wait for the stream to complete, and automatically resolve the final emitted value. You have the ultimate flexibility to choose whichever async pattern best fits your architectural needs. Okay, let's step back and look at the beautiful reception desk workflow we've just built. Step 1. We cleanly route incoming HTTP requests using simple class and method decorators. Step 2. We extract exactly the data we need using parameter decorators like @body and @query. Step 3. We effortlessly await asynchronous operations from our service layer using promises or observables. And finally, step 4, we simply return the value, letting the standard auto-serialized JSON response handle all the formatting and status codes for us. These 4 steps completely replace those messy 1,000-line routing scripts we talked about earlier with a highly organized, declarative architectural layer. So, as we wrap up this explainer, I want you to take a hard look at the code you work with every day. Ask yourself, are your current API routes a tangled mess of spaghetti logic, or are you ready to embrace a structured approach and build a proper reception desk for your application? NestJS controllers provide the exact framework you need to keep your app's front door clean, efficient, and endlessly scalable. Go check out the NestJS documentation and start refactoring those routes. Thank you so much for joining me today, and as always, keep learning and keep building.